Every single day, we see the same thing, right? The sun comes up in the east, travels across the sky, and sets in the west. It feels totally obvious that the sun is the one doing all the moving. But what if that feeling, that thing we see with our own eyes every day, is actually wrong? Today, we're going to tackle that ancient puzzle. We're going to flip our whole perspective on where we really are in the cosmos.
And our investigation doesn't start with some crazy powerful telescope or anything like that. Nope. It all begins with a super simple observation, something anyone can do, right here on the ground. But this one little thing, it casts a shadow of a doubt on everything we think we see.
So this brings us to the big one, the fundamental question that people, scientists, philosophers, you name it, have been wrestling with for literally thousands of years. Are we just sitting still watching the sun make its daily trip across the sky, or are we the ones who are actually moving?
And this exact puzzle actually popped up for a student named Rashmika. She noticed something pretty cool, that shadows were really long in the morning, but by the afternoon, they got super short. Her first thought? Okay, the sun must be moving. But then she remembered something she learned in school. The Earth is the one that moves around the sun. Wait a minute, both of those things can't be true, can they? And that contradiction is exactly what we're going to get to the bottom of.
All right, to really make this click, let's try a simple analogy. I want you to forget about space and planets for just a second. Instead, picture yourself at a playground. Okay, so imagine you're sitting right on this merry-go-round. As it starts to spin up, you look out at, the trees, the park benches, whatever's around you. Now those things are stuck to the ground. They're not moving. But from where you're sitting, it absolutely 100% looks like they are the ones spinning around you. This feeling, this illusion, that's the core idea here. It's called relative motion.
Let's just break this down for a second. From your perspective, right there on the ride, it feels like you're just sitting still. But what you see is the whole world just rushing past you in the opposite direction. It's a really powerful illusion, and it's all created by your brain based on your point of view, what scientists call your frame of reference.
Okay, so now let's take that exact same idea and apply it to our planet. What if the Earth is basically just a giant cosmic merry-go-round? And the sun, which looks like it's moving, what if it's really just like one of those stationary trees off in the distance? That, right there, is the huge perspective shift we need to finally solve this puzzle.
So, let's dive into the first big piece of this puzzle, our planet's own movement. And this isn't just an analogy anymore. This is real. The Earth is genuinely, truly spinning all the time.
Now, the official sciencey term for this is rotation. And really, it's just a fancy word for an object spinning around a central, imaginary line. Think about a spinning top or a basketball spinning on someone's fingertip. That's rotation.
So for our planet, that imaginary line, we call it an axis, runs straight through the North and South poles. And the Earth spins on this axis from west to east. One full turn? That takes about 24 hours. And listen, this isn't just some random trivia fact. This one motion explains pretty much everything about our daily lives.
And check this out. This simple setup perfectly shows the biggest consequence of all this spinning. Think of the flashlight as our sun, and the globe, well, that's the Earth. And as you can see, it doesn't matter how you hold them, only one half of the planet can ever be lit up at one time.
So, as the Earth spins, different parts of it are constantly moving into the light and then back out of it. The side that's facing the sun, that's what we call day. And the side that's turned away from the sun, that's night. It's this nonstop rotation that creates the fundamental rhythm of day and night for literally everyone on the planet. Okay, but here's the really crucial part. This daily skin, it doesn't just change our view of the sun. Oh no, it changes our view of the entire universe. It basically turns our night sky into a giant cosmic clock.
And that leads to a pretty logical question, right? I mean, if the Earth is really spinning like a top, shouldn't the stars, which are kind of like those stationary trees in our merry-go-round analogy, shouldn't they also seem to drift across the sky all night long?
And the answer to that is a huge definite yes. I mean, just take the Big Dipper, for example. If you actually go outside and watch it over a single night, you'll see that it looks like it's moving. It might pop up low in the northeast early in the evening. Then it'll climb way up high by midnight and end up over in the northwest just before the sun comes up. The stars aren't moving an inch. We are the ones turning underneath them.
And, this is not some newfangled idea. The brilliant Indian astronomer Aryabhatta,
He figured this out perfectly over 1,500 years ago. He compared it to being on a moving boat. When you're on the boat, the shore looks like it's moving backwards, right? But you know it's the boat that's actually moving. Well, it's the exact same idea for us here on Earth, watching the stars go by.
But okay, that daily spin, that only explains the 24-hour cycle. There's a second, much bigger, much grander motion going on. And this one explains why our view of the universe changes over the course of an entire year.
Which brings us to the next big puzzle. If rotation explains why the stars seem to move every night, then why do we see totally different constellations in the winter than we see in the summer? Why do certain star patterns seem to signal the start of a new season? Rotation by itself just can't explain that.
Well, the answer is a totally different kind of motion called revolution. So at the same time the Earth is rotating on its axis, it's also moving along this giant path, an orbit, around another object, the Sun. And that is our year-long journey.
And this image does a fantastic job of showing you the effect of that journey. Just think about it for a second. As the Earth travels to all these different points in its orbit around the Sun, the night side of our planet, which is basically our window to the universe, is pointing towards a completely different patch of space, a whole different backdrop of distant stars.
So we can actually trace this out over a year. Let's say in March, our nighttime window is pointing in one direction. Okay, fast forward to June. We've moved a quarter of the way around our orbit and boom, our view has shifted. By September, it changes again. And then by December, we're all the way on the other side of the Sun, looking out at a totally different field of stars than we saw back in March.
And here's a final piece to the puzzle. It's this revolution, this year-long journey, combined with the fact that the Earth's axis is actually tilted. That's what gives us our seasons. So it's not just about what we see, but about how the sun's energy hits our planet differently as we travel around. But you know what? That's a whole other story for another day.
So there you have it. We are not just standing still, not even close. We are all passengers on a planet that is constantly spinning, orbiting, and tilting on this incredible, endless journey through space. It really makes you wonder, doesn't it? What other huge cosmic motions are we a part of right now that we can't even feel? Thanks for joining me for this one.